हेलो स्टूडेंट्स, इस वीडियो में हम देखने वाले हैं जो हमने रूल 1 और रूल 2 की कुछ प्रॉब्लम्स लास्ट दो वीडियोस में की थी और हमने देखा था कि रूल 1 और रूल 2 से कैसे हमें डिफरेंशियल इक्वेशंस को एग्जैक्ट डिफरेंशियल इक्वेशन में कन्वर्ट करना है। तो आज हम यहाँ पे एक बार देखने वाले हैं कि हाउ वी गेट दोज रूल्स, वो रूल्स और वो इक्वेशंस हमारे पास आती कैसे हैं। सो लेट्स स्टार्ट। तो एक बार मैं फटाफट से यहाँ पे लिख देता हूँ। हमारे पास रूल नंबर 1 था, राइट। वी हैड रूल नंबर 1, डेल एम बाय डेल एक्स, डेल एम बाय डेल वाई, सॉरी, माइनस डेल एन बाय डेल एक्स अपॉन एन इज इक्वल टू एफ ऑफ एक्स. This requirement was there to get an integrating factor of e raised to integral of f of x, right. Similarly, rule number 2 was almost similar to this. Similarly, rule number 2 was that del n by del x minus del m by del y divided by m, if this is a function of y, then our integrating factor was e raised to f of y, right. So these were rule number 1 and 2. But how we get these rules? Like, uh, if you are not interested in these derivation and all that, it's okay. Knowing the rules is quite useful in mathematics, especially in physics. If you don't know these rules, it's fine, but in the long run it's good to know the derivation slash, like, how we get from where do we get these rules. So let's see. So let's start with a general differential equation. Like, we have this equation m of xy dx plus n of xy dy is equal to 0. If we have this form of differential equation, and we see that when we do del m by del x uh, and del n by del y, sorry, actually this should be reversed. When we do del m by del y and del n by del x, if they are not equal, then what we are trying to do here is we try to multiply these both sides with some another function. Let's say it is r of xy. So our strategy is that we will multiply with it some function r of xy, hoping that after multiplying the equation which we get, in that this equation is this condition is there. So let's multiply this with some function r of xy. So after multiplying, we will get something like r of xy times m of xy. Like, these are all functions of x and y both. That's why I am explicitly writing that these are functions of xy, so that you keep in mind that these are function of x and y both. All of these, x y dy is equal to 0, right. Now in this case, this whole thing is the new m, right. So I will call it m dash, and this whole thing is the new n. Now after I have multiplied it with some function, this whole thing is the new n, so I will call it n prime. And now the condition which we need to satisfy in order for this new equation to be exact is del m dash by del y, this should be equal to del n dash by del x, right. This is exactly what we want. If after multiplying with r of xy we are able to get this with our new n and m's, then we got a exact differential equation, right. So let's direct let's just differentiate these and see what we get. So if we take these and differentiate these, let's take the differentiation of m dash with respect to y only. So what we will get is del r by del y into m plus del m by del y into r. Right now I am not writing these x and y's, because by now it is clear that they are all function of x and y by far. And here we will get del r by del x into n plus r into del n by del x. Simple, right. In order for this condition to be correct, uh, uh, this equation should hold. Right, now what we can do is let's take these r terms, the terms which have an r in them, let's take them on one side. These terms, let's take them on one side, and these terms which have the derivative of r on one side. So if we take them on different side, we will get, here we will get del r by yeah, wait a minute, yeah, let's take r terms here. I will get r del m by del y minus del n by del x. These green terms, these I have accumulated here, is equal to del r by del x into n minus del r by del y into m. Right, now this equation, take a look at this equation. Right now it is not easy to find r here, right? R is a function of x, y, and we have derivative of y with respect to, right, derivative of r with respect to y with respect to x. So like this is not an easy to solve differential equation. Like we can't find r from here, like which r we should multiply to make this equal. We can't easily find r from here. So we will take some special cases which will make our life easier in solving this equation. So first of all, let's take case 1, in which what we are going to do is, let's assume that r is actually just a function of x, right? So r is just a function of x, there is no y in this. So what this will do is, as a result, del r by del y will be 0. So in this equation, if del r by del y is 0, this term is 0, then this factor is gone, right? All we have remaining is this. So we can directly just copy this, right? Let's just copy paste this. So if r is only a function of x, then we get this condition. Now it's quite a nice solvable equation, because now since r is just a function of x, we can actually change this to dr by dx if we want, because since it's just a function of x, so it's okay to write this. Now I will send this n in divide there. So now we will get this del m by del y minus del n by del x divided by n into r of x. Let's write it as r of x for a while. So is equal to del r by del x. Now what we are saying, that this whole thing, if this is some function of x, right, because we know m, we know n, we know these derivatives. So this whole thing we can always find after we have a differential equation to solve. So this thing we can always find. And what we are saying, that if this thing happens to be a function of x, then we can write this whole equation as f of x rx is equal to dr by dx. And now we can see that this is quite an easily solvable differential equation. So we are very close to finding this r. So we can write this as dr by r is equal to f of x dx. Then we can integrate both sides. Then here we will get ln r is equal to this integral fx dx. Now we can take exponential, and finally we see that we get this r of x is equal to e raised to integral of f of x dx. Right, so this is exactly rule number 1, right? This thing which we have got, this is the integrating factor which we use in rule number 1, right? And this f of x, it is the same thing which we use in rule number 1. This is exactly what we use in rule number 1, this, right? So this is how we actually get rule number 1. So now let's take a look at rule number 2. So for rule number 2, we will take another case. For like in case 1 we had r of x, we took r as a function of x only, right? So in case 2, what we can do is, okay, I can maybe, let's start over. We can remove all this, right? So in case 2, what we are going to do is, you can maybe guess right now that in case 2 we are going to take r, we are going to take our old r, and this time we are going to take it as a function of y only, right? So as a result, del r by del x will be 0 this time, right? And in this equation which we got above, where we have generalized r as a function of x y both, right, this time this equation will be 0, right? So let's copy down the rest of the equation. We already had it, right? This time del r by del x will be 0, so here we will get this term minus del r by del y times m, right? The only this term will survive. This term I am writing over here, del r by del into y, where, and there is a minus sign also here, right? So now again we have a similar situation as we had earlier. So what we need to do now is just simply we need to solve this differential equation, and we will easily find this r. So again let's write this down, del m by del y minus del n by del x divided by m is equal to, and there is r, and we can also put the minus sign here from the right hand side, is equal to del r by del y. Now again what we are saying is that if this whole thing happens to be a function of y, a function of y only, then we can write this equation as, okay, let's actually take this minus sign and distribute it inside, so that it actually looks similar to our rule number 2, right? I have inserted these minus signs here. Let's say this is function of y, then we can write our equation again as r times f of y is equal to dr by dy. That again when you will solve this is exact same case as before. There we had just x, here just we have just replaced this variable, everything else is same. So when you solve this again you will get, I am not showing the whole page, it is exactly same as the case 1, integral of f of y, right? So again you can see that this integrating factor is exactly same as the rule number 2 integrating factor, and this f of y is also exactly same as the integrating factor that we had in rule number 2. So this was the derivation of rule number 1 and 2, and it is nice to know these derivation because it kind of motivates you to actually know how we get different rules in mathematics, because math is all about linking all the equations we have with our previous knowledge. So yeah, so in next video we will go over rule number 3, and after that maybe we can also take a look at the derivation of rule number 3. One more thing, these derivation which we are doing by multiplying r of x y, right, and then assuming something, these are we can say that these are quite lucky that we are able to get these nice beautiful functions r of x, nice these integrating factors, which after multiplying these we are able to get some nice solutions of our differential equation. This is not always the case, right, but it's nice to know that we can try these kind of techniques in order to solve our differential equation. So I hope you liked this video, and I will see you in the next video.